Welcome back, pre-calculators and trigonometers. We are looking today at polar coordinates and how they relate to rectangular coordinates. The coordinates that you have always dealt with in the past are rectangular coordinates, in other words, x and y. Polar coordinates is a new way of looking at a point's location, really more in the way that we look at things on the unit circle. It doesn't only apply to the unit circle, but it's more in the way of its location is based on how far away from zero it is and what angle it is in terms of rotation. It's kind of like this. If I have a point, I can think of this exact same point as either the point x, y, I go over x and up y to get there, or I can think of it as the point where I revolve from zero an angle of rotation of theta, and I go out from the center the distance of r. So I can think of it as r theta. So they're really just two different ways of referring to the same point. And pretty much everything that we're going to talk about here today really comes back down to this picture, and you could figure it out in terms of this picture and in that context. When we look at polar coordinates, we look at them more on a coordinate plane or a polar coordinate plane that's basically kind of like the unit circle. And I'm trying to see this. These are really small, so it's kind of hard to see these. But that's okay, because we're going to look at it in degrees and radians, and I think these are just in degrees. But we look at it in the context of this kind of a plane, as opposed to having just the square grids, the rectangular coordinates that have those little square grid. Okay, so let's look at a few different things here. First of all, we're going to figure out how to use that particular polar coordinate plane. And we're going to do that by looking at how we would take this and find a point on it. Okay, so remember the first coordinate, that's your r, and the second coordinate is your theta. So this is not left and right and up and down. This is looking at it just in a different way. Now, r stands for radius. So the radius of a circle is how far out from center to that circle, right? That's the length of the radius. So this smallest circle you see has a radius of 1. The next circle out has a radius of 2 because it's 2 units to get there. The next circle out has a radius of 1, 2, 3, and so on, with the biggest one having a radius of 4. So the fact that it says radius of 4 means it's going to be somewhere on that biggest circle. So then we use the angle, and this one is in degrees, just the same way we do when we're doing a unit circle. Okay, in other words, 0 is over here, and then this is 90, and 180, and 225 would be right in the middle of the third quadrant. And so I put my point on the fourth circle out at an angle from 0 going around counterclockwise 225 degrees. So that is the polar coordinate location of that, or the location of that point in terms of polar coordinates. Okay, let's look at one that is not in degrees, one that is in radians. Okay, so again, the first coordinate is your radius. So that's how many circles out from the center. Okay, so I'm going to go to the second circle because that's the circle that has a radius of 2. So I know that my point is going to be somewhere on the second circle out, the second biggest circle. And then I'm going to go from 0 over here around that circle till I get to the point where 2/3 or 2 pi over 3 would be, which is right here. 2 pi over 3 is the same as 120 degrees. So this is the location of that point. All right. Next two. And if you need some little polar coordinate templates like this, embeddedmath.com has some great ones. That's actually what I'm using right here. So if you go to embedded, E-M-B-E-D-D-E-D, math.com, you can find one. So now let's talk about this. This is new, the negative. All right. If this were not there, if this was just 3 pi over 4. Then I would go out to the third circle and I would go up to pi over 4 and it would be right here. I'm going to put an X where it would be. Now, this is not where that point is though. Basically, when we have a positive radius, that means I go out 1, 2, positive 3 circles to get there. If you have a negative radius, that means you figure out where that angle is, and then you go backwards on that same line that goes through the center. So in other words, this is the line that relates to pi over 4, this whole line, and instead of going toward pi over 4 from 0, 0, because it's negative, I'm going to go away from pi over 4, 1, 2, 3 circles, and this is that point. Okay, so another way of looking at this is, since 180 degrees from pi over 4 is 5 pi over 4, you could say that that point is positive 3, 5 pi over 4. Because you're going 1, 2, 3 circles times toward 5 pi over 4, or 1, 2, 3 circles away from pi over 4. And we're actually going to talk next about doing exactly this, talking about 2 different ways or multiple different ways, 4 or 5 different ways of describing the same point. Last one we want to do together here, negative 1, 135. When it's negative, I really kind of think it's helpful to find the angle first. So the angle 135 is right here. So if I start at 0, 0, if it was positive 1, 135, I would go out toward 135, 1 unit, and stop. Since it's negative 1, 135, I'm still going to stay on that same line. Let me grab a highlighter real quick. So on this same line, but I'm not going toward 135 from 0, 0. I'm going away from it 1 unit, and I stop. And so this is the location of that particular point. All right, next up, another common question you are asked is to find multiple ways to describe a particular point. So find multiple sets of polar coordinates for a given point. Okay, so let's think about where this one is. 5 and 5 pi over 3. I actually picked one. This is not the best because it's hard to see on here because we only have 4 circles. But 5 would be the next circle out. So if we had one more circle, okay, so the radius of 5, and the location 5 pi over 3. 5 pi over 3, this is 1/3 pi, 2/3 pi, 3/3, 4/3, 5/3 is right here. So if I'm going to go to the point 5, oh, you can't see it, there it is. Point 5, radius 5, 1, 2, 3, 4, 5 circles out toward 5 pi over 3. That's where I am. All right, now one particular thing, my students aren't being asked this in their online assignment. Actually, they are not being asked the following, but it's a very common question. It's very common for books to ask you to come up with 3 others. And if I were asked to come up with 3 others, here are the 3 I would naturally go to. Basically, if you think of there being 4 equally good ways to describe this point, or 4 of maybe the most basic 4 ways to describe this point, because really there are infinitely many ways. Remember, points that are coterminal, I could keep going around the circle in different directions and come back to that point and name it a different way. But the 4 equally good ways, or the 4 most basic ways perhaps, would be positive or negative radius and positive or negative angle of rotation. Okay? In other words, let's go ahead and say I'm going to do another one with a positive 5 radius. Okay, but this time I'm going to go, instead of a positive angle of rotation, I'm going to go negative angle rotation. So I keep the radius the same and I change whether I'm rotating positive direction or negative direction. Remember, positive direction is counterclockwise, negative direction is clockwise. So I'm starting here as 0 and I'm rotating clockwise. That's 1 pi over 3, 1/3 pi in the negative direction. Okay. One helpful hint here, if I take this and take away the sign. In other words, if I think of that as 1 pi over 3, 1/3 plus 5/3 equals 6/3, which is 2. 2 pi is all the way around the circle. That's always the case. If you ignore the negative and add these two together, you would get something that's the equivalent of 2 pi. Okay, in other words, 5 pi over 3 plus 1 pi over 3. That's just a way to sort of check yourself. All right, so now I have the same two that have the same exact radius, but I changed the sign of the angle basically, which is the direction of rotation. So now I'm going to go ahead and figure out what I would have if I changed the sign of the radius. Okay, now, same line, but basically now we're thinking of going to this point as going backwards away from our angle, which means our angle has to be up here. So to get to this point as a -5 means I'm looking at this angle and going away from it 5 circles. So I have to figure out what this angle right here is. And that angle is 2 pi over 3. Or if I go negative in terms of my rotation, okay, so same radius, but now the negative angle of rotation, that is 1/3, 2/3, 3/3, 4/3, -4 pi over 3. And again, if I ignore the sign and add those two up, I'd get 6 pi over 3, which is 2 pi, which is the same as all the way around the circle. So there's 4 different ways to represent that same exact point. All right, let's do another one like that. All right, find multiple sets of polar coordinates for a given point. This one has a radius of 10 and an angle of pi over 3. So I'm not going to use the grid because I don't have 10 circles. So let's just assume this has a radius of 10. One of the worst circles I've ever drawn, sorry. So let's say this has a radius of 10, which means like this is 10, 0. Okay. So the angle here is pi over 3. So that's right up here. So we're going out 10. Another way of thinking of it is this distance is 10 to pi over 3. First one I would probably do is keep the radius the same and change the angle of rotation. So instead of going this way, go back around the other way to get there. So instead of 1 pi over 3, it's going to be -1, 2, 3, 4, 5 pi over 3. Feels like we just used some of these numbers. And then for -10, that means I'm going 10 away from 0 or away from the angle, which means the angle I'm looking at is whatever the angle is down here. And I'm standing at 0, 0, and I look at the angle and I go backwards 10 away from it. So that would be one way of getting the angle is add 180. That's a half circle, or pi, just pi. So pi is 1/2 of the circle, right? So that's 4 pi over 3. Or you could have said, oh, I know that that's 4 pi over 3. So this is going to be +4 pi over 3. And then the last one I'm going to do is the same exact radius, -10, but instead of going around +4 pi over 3, I'm going to go -2 pi over 3 to get there. Okay, there are different ways you can be asked for these. Sometimes they will specify and tell you to find one, for instance, where the radius is 0 and your angle is between 0 and -2 pi. Well, the one that I would choose is this one because that has a negative radius, and this is between 0 and -2 pi. It's a negative angle of rotation.